200,000 American citizens are inside the forecast cone of a storm projected to arrive at Category 5 strength this weekend. Typhoon Bavi is intensifying explosively east of Guam, with winds forecast near 173 miles per hour and 45-foot seas. And the islands in its path are still rebuilding from the last typhoon just 3 months ago. In the next 20 minutes, you'll see who is in the path, why this storm exploded overnight, and the one detail that decides whether this becomes historic. Yesterday morning, the National Weather Service Forecast Office on Guam issued a Typhoon Watch for Guam, Rota, Tinian, and Saipan. A separate tropical storm watch went up for the northern islands of Alamagan, Pagan, and Agrihan. The storm behind those watches is Typhoon Bavi, the ninth numbered system of the Western Pacific season, and the language forecasters attached to it was unusually blunt. Typhoon Bavi intensifying rapidly east of Guam. The numbers in that watch are the kind that make forecasters stop what they are doing. Sustained winds near 150 knots, roughly 173 miles per hour. Gusts to 180 knots, which converts to about 207 miles per hour. Seas building as high as 45 feet. For reference, Category 5 on the Saffir-Simpson scale begins at 157 miles per hour. This forecast doesn't flirt with that line. It clears it with room to spare, and the timing is compressed. The watch stated that typhoon conditions, sustained winds of 64 knots or greater, are possible within the next 24 to 48 hours. That is not a storm on the horizon. That is a storm at the door. Here is what makes this different from the routine typhoon coverage you may be used to scrolling past. The Western Pacific produces more tropical cyclones than any basin on Earth, and most of them spin harmlessly over open water. Bavi is not doing that. Bavi is strengthening explosively while aimed directly at the only sizable population of United States citizens anywhere in its path. The Mariana Islands are American soil. The people under that watch are Americans. And a storm that was barely a tropical system 3 days ago is now forecast to arrive at their coastline as one of the most powerful storms on the planet. We are going to walk through exactly what happened in the last 72 hours, who is in the path, why the storm exploded the way it did, and this is the part almost nobody is talking about, why the true strength of this typhoon is, right now, a well-educated guess. And it gets more unsettling from here. 2 days ago, Bavi was nothing special. On Thursday, July 2nd, the storm center sat roughly 960 miles east of Guam, crawling west-northwest at about 15 miles per hour, with 1-minute sustained winds near 60 miles per hour. The period before that, it was at 45. Those are the numbers of a garden-variety tropical storm, the kind that forms and dies in that basin a dozen times a season. Then, the ocean got hold of it. Within roughly 24 hours, Bavi went from forecast to strengthen, no watches in effect, to an official Typhoon Watch on United States territory with a projected Category 5 equivalent peak. The Joint Typhoon Warning Center now forecasts the storm to top out near 155 miles per hour tomorrow, July 5th. The Japan Meteorological Agency already classifies Bavi as a very strong typhoon, with central pressure near 925 hectopascals and falling. Forecasters have a formal definition for what this storm is doing. Rapid intensification means a storm gains at least 30 knots of sustained wind, about 35 miles per hour, within 24 hours. It is the single most dangerous behavior a tropical cyclone can exhibit and the hardest to predict. The storms that kill the most people in the modern satellite era are usually not the ones that stayed strong for a week while everyone watched. They are the ones that went from manageable to catastrophic in the final day or two before land, faster than warnings could keep up, faster than people could board windows or move boats or leave. Bavi is running that exact play right now on a track that gives the people in front of it almost no margin. Keep that 30-knot definition in mind, because Bavi didn't just meet it, Bavi lapped it. And the water it is crossing is the reason why we'll get there. First, you need to see who is standing where this storm is going. The exposure zone is home to roughly 200,000 United States citizens and nationals. Guam alone holds about 153,000 residents, along with one of the most strategically important American military footprints anywhere in the Pacific. The Commonwealth of the Northern Mariana Islands, Saipan, Tinian, and Rota, adds roughly 47,000 more. Every one of those islands is under a watch as of yesterday. Islands change the math of a storm like this in a way mainland coverage rarely conveys. When a major hurricane approaches Florida or Texas, the standard playbook is movement. Evacuate the coast, drive inland, put 100 miles between yourself and the eye wall. On an island 30 miles long, there is no inland. There is nowhere to put distance. Shelter is the only play, and shelter against 200-mile-per-hour gusts and 45-foot seas is a very different proposition than shelter against a Category 1. The numbers on the sea state deserve their own moment. 45-foot seas are not surf. They are moving walls of water the height of a 4-story building, arriving one after another for hours. Every harbor, every mooring, every reef line, and every coastal road in the watch area is exposed to that. On islands where the ports are the lifeline for food, fuel, and everything else that arrives by ship, the sea state alone, before a single gust touches land, threatens the supply chain the recovery will depend on. The calendar makes it worse. Recommended preparations were to be complete by today, the 4th of July. Peak impacts arrive tomorrow into Monday. That means the entire preparation window for a possible Category 5 landed on a holiday weekend, when families are cooking out, businesses are closed or short-staffed, and attention is anywhere but the forecast. Emergency managers plan for complacency in the best of times. A holiday compresses an already short runway, and there is one more layer. The mainland news cycle this weekend is dominated by record heat, fireworks, and travel. A storm threatening Guam and Saipan, American citizens, American soil, will receive a fraction of the coverage that an identical storm aimed at Miami would get. That is not a conspiracy. It is a long-documented pattern of attention. And it matters, because national attention drives resources, urgency, and aid. 200,000 Americans are about to take a punch most of the country will never see thrown. What that punch looks like depends on a forecast detail measured in a handful of miles, and that detail is still unresolved. The major forecast models agree on the big picture and disagree on the detail that matters most. The American GFS model has favored a track that brings Bavi's core toward Tinian and Saipan. The European ECMIWF model has leaned farther south, toward Rota and Guam, before the storm moves on into the Philippine Sea. Longer-range guidance takes whatever is left of Bavi toward Luzon, Taiwan, or Japan next week. But for the Marianas, the next 48 hours are the whole story. On islands this small, that model split is not an academic detail. The distance between those two tracks is a few dozen miles, and it is the difference between a direct core passage and a near miss, between catastrophic and merely severe. A typhoon's most violent winds live in a ring around the eye that may be only 20 or 30 miles across. Put that ring over Tinian, and Tinian is dismantled while Guam takes a hard but survivable hit. Slide it 60 miles south, and the outcome flips. The current centerline forecast from the Joint Typhoon Warning Center threads the needle in the worst way for the northern islands. A pass just south of Tinian, around Sunday night into Monday morning, island time, near peak intensity. If that verifies, this becomes a historic event for the Marianas. And the word historic is doing real work in that sentence, as you're about to see. There is also a timing wrinkle inside the track question. The closer to peak intensity the core arrives, the smaller and more violent that inner ring tends to be, which raises the stakes of every wobble. A storm that has just finished strengthening delivers its worst over a narrower footprint, meaning the difference between devastation and a bad night can shrink to a distance you could drive in half an hour. Rainfall adds a second blow, regardless of exact track. Guidance suggests storm totals on the order of 10 to 18 inches across the affected islands. Flash flooding and mudslide rain arriving alongside the wind and a battering sea. Whichever island takes the core, nobody in the watch area escapes the water. And for these specific islands, all of this is landing on communities that have not finished repairing the damage from the last one. The Marianas have been here before, and recently. In April of this year, Typhoon Sinlaku struck the same island chain, and parts of Guam and the northern Marianas are still rebuilding from it. Roofs are still tarped. Infrastructure repairs are still in progress. A population that took a major hit in spring is now staring down a forecast that reads worse, barely 3 months later. Recovery windows in the western Pacific are supposed to be measured in years. These islands are getting months. The longer history is just as unforgiving. In 2018, Super Typhoon U2 crossed Tinian and Saipan with winds around 180 miles per hour, destroying thousands of homes and leaving the islands without power for weeks, the strongest storm to strike any part of the United States that year. In 2002, Typhoon Pongsona raked Guam with damage in the hundreds of millions. In 2023, Typhoon Mawar knocked out virtually all of Guam's power grid. The Marianas sit in the most active typhoon corridor on Earth, and they carry the scar tissue to prove it. That history is exactly why yesterday's watch language matters. The forecasters at the Guam office have seen U2 and Mawar up close. They do not reach for the phrase intensifying rapidly to add drama. When that office puts 150-knot winds and 45-foot seas in a public product, it is because the data forced their hand. So the stakes are set. A possible Category 5, aimed at American islands still patching themselves up from the last storm, arriving on a holiday weekend. Now the question becomes, how a 60-mile-per-hour afterthought turned into this in barely 2 days? The answer starts with what this storm might become before it gets there. Because Bavi isn't just threatening these islands, it is threatening the record books. July is not supposed to produce storms like this in the Marianas. The peak of the western Pacific season runs from August through October, and a storm of Bavi's projected strength making a direct pass through these islands in early July would be a candidate for the strongest July typhoon ever to do so. Forecast offices do not use the phrase on record loosely, and that is the territory Bavi's forecast now occupies. Some of the model guidance has gone further. Outlier runs of the European model have flirted with central pressures in the 871 to 883 hectopascal range. To understand how extreme that is, you need the yardstick. Typhoon Tip, in 1979, holds the all-time record for the most intense tropical cyclone ever measured on this planet, with a central pressure of 870 hectopascals and winds near 190 miles per hour. The outlier runs are not the forecast. The official forecast is meaningfully more conservative, but the fact that credible model physics can even produce numbers in Tip's neighborhood from this storm in this month tells you what the ocean out there is capable of supporting right now. Lower pressure means a stronger storm. The lower the central pressure, the harder the atmosphere around it drives wind toward the center. When a model starts printing values within a dozen hectopascals of the strongest storm in recorded history, the honest takeaway is not that the record will fall. It is that the ceiling in the Philippine Sea this week is extraordinarily high. And that ceiling is set by something you cannot see from a satellite photo, the temperature of the water, not just at the surface, but far below it. That is the engine, and it is worth 2 minutes to understand because it explains everything Bavi has done since Thursday. A typhoon is a heat engine, and its fuel gauge is not the sea surface temperature you see quoted in headlines. The surface reading matters, and right now the Philippine Sea east of Guam is running 29 to 31 degrees Celsius, bathwater by ocean standards. But the number that decides whether a storm merely strengthens or explodes is how far down that warm water extends. Meteorologists track the depth of the 26-degree layer, a measure called tropical cyclone heat potential. Think of surface temperature as what's visible at the top of the fuel tank, and heat potential is how much is actually in the tank. Here is why that matters. A typhoon's own winds churn the ocean violently, dredging up water from below the surface. If cool water sits just underneath, the storm pulls its own coolant. It chokes on the upwelling and levels off. That is the built-in brake that stops most storms from ever reaching their potential. But if the warm layer runs hundreds of feet down, the churning brings up more warm water, and the engine never starves. The brake line is cut. The patch of ocean Bavi is crossing is the largest reservoir of warm water on the planet, the Western Pacific Warm Pool. It is the same stretch of sea that has built the majority of history's most powerful storms. And this week, it is delivering an almost frictionless environment. Warm water with no cool layer beneath it, low wind shear that would otherwise tear a developing core apart, and strong outflow aloft, venting the storm's exhaust. When forecasters describe a textbook rapid intensification setup, this is the textbook. Bavi also did its part internally. Explosive strengthening usually requires the storm to organize a tight, clearing eye and align its core vertically, the structural tune-up that lets the engine convert all that ocean heat into wind. Once Bavi's core snapped into alignment over that bottomless fuel supply, the sprint began. 60 miles per hour Thursday. A projected 155 by tomorrow. The physics permits it, the ocean is funding it, and there is a bigger reason this keeps happening, one that extends well past this weekend. Every storm has a theoretical speed limit. Atmospheric scientists call it maximum potential intensity, ceiling set by the heat available in the ocean below and the temperature of the atmosphere above. The warmer and thicker the ocean's upper layer, the higher that ceiling climbs. Bavi is not breaking the rules of physics. The rules themselves have been shifting. The Pacific is running warm. The official ocean temperature index that tracks El Niño has climbed from minus 0.55 last autumn to plus 0.48 now, technically neutral, but warming fast, with the key monitoring region sitting above 28 degrees Celsius, a warmer background. Pacific does two things at once. It raises surface temperatures, and it thickens that critical warm layer below the surface, topping off the fuel tank that rapid intensification draws from. And the pattern is bigger than this year. Peer-reviewed research over the past decade, including analyses published in Nature Communications, has found that the proportion of storms undergoing rapid intensification has been rising as the upper ocean warms. The most alarming version of that trend is exactly the Bavi scenario. Storms that make their biggest jumps close to land, converting a 2-day warning into a 2-day emergency. To be clear about what the science does and does not say, no single storm can be attributed to a warmer baseline, and Bavi would have been dangerous in any era. What the warming trend changes is the frequency of the worst case. Explosive spin-ups like this one used to be outliers. The data says they are becoming a recurring feature of the landfall problem, and if you watched our coverage in late June, you saw the strongest June typhoon in 22 years pull the same explosive move in this same basin. That was 10 days ago. Bavi is now forecast to be stronger. Twice in one summer, the Western Pacific has built a monster on an accelerated schedule, and that brings us to the most uncomfortable part of this story. For a storm this dangerous, the numbers we have are estimates. Nobody is actually measuring them. In the Atlantic, when a hurricane threatens the United States, aircraft fly into it. Hurricane hunter crews punch through the eye wall multiple times a day, dropping instruments that measure wind, pressure, and temperature directly inside the storm. Those flights are the gold standard of intensity data, the ground truth that anchors every forecast you hear. There are no routine hurricane hunter flights in the Western Pacific. None. The most active tropical cyclone basin on Earth, the one currently aiming a possible Category 5 at 200,000 Americans, is monitored almost entirely from orbit. Intensity estimates for Bavi come primarily from the Dvorak technique, a method developed in the 1970s that infers a storm's strength by pattern matching its appearance in satellite imagery. Skilled analysts read the shape of the eye, the temperature of the cloud tops, the symmetry of the core, and translate what they see into a wind speed. The method works from pattern recognition, and patterns have limits. Two storms with nearly identical satellite presentations can differ meaningfully in actual wind speed, and the technique was calibrated in an era with far fewer extreme storms to learn from. Microwave satellite passes and other modern tools have tightened the estimates, but none of them replaces an instrument physically inside the eye wall reading the wind directly. The Dvorak technique is a remarkable tool, refined over 5 decades and validated against thousands of storms. But at the extreme end of the scale, exactly where Bavi is operating, its error bars widen. A storm estimated at 150 knots from satellite could genuinely be a category stronger or weaker. The 150-knot figure in yesterday's watch is the best estimate available from some of the best analysts in the world. It is still an estimate. Sit with what that means for the islands. The precise strength of the storm bearing down on Guam and Saipan may not be truly known until it is nearly on top of them, when it finally crosses land-based radar and instruments, or until the damage itself becomes the measurement. The forecasters are not hiding this. They openly flag the uncertainty in their own discussions. It is a structural blind spot, a limitation of the observing system. And this weekend it means 200,000 Americans are preparing for a storm whose headline number carries an asterisk. The people reading those satellite images know exactly how much is riding on their estimate. And predictably, that uncertainty has become raw material for a very different kind of story online. A viral claim circulating this week says Bavi is being engineered or steered toward Guam's military installations by weather modification technology. A companion theory credits the geomagnetic storm arriving this same weekend with powering the typhoon. The energy budget dismantles both. A mature typhoon continuously releases energy comparable to many times the entire planet's electricity generation. No facility humanity has ever built operates within orders of magnitude of that scale. And cloud seeding, the real technology the claims lean on, nudges individual clouds under narrow conditions. It does not build Category 5s, and it cannot steer them. Storm motion is governed by the subtropical ridge and mid-level winds, which are observed and modeled in the open. As for the solar storm, geomagnetic activity acts on the upper atmosphere and the magnetic field. It adds no heat to the ocean, and the ocean is the engine. Space weather and surface weather are separate systems, and this weekend they are simply coinciding. The truth here needs no embellishment. A Category 5 aimed at American soil is dramatic enough. Here's the timeline in front of us. Today, the 4th of July, is the last full preparation day for the Marianas. The watch guidance called for readiness before conditions deteriorate. Tomorrow, Sunday, July 5th, Bavi is forecast to reach its peak, near 155 miles per hour, as it closes on the islands. The projected closest pass comes Sunday night into Monday morning island time, threading near Tinian, with the exact track, and therefore the exact outcome, still hinging on that split between the American and European models. Watch for 3 things as this unfolds. First, watch for the watches to become warnings. That upgrade will likely come today, and it will sharpen the timing. Second, watch the intensity estimates in each new advisory. If the satellite analysis pushes past 150 knots while the storm is still east of the islands, the record book scenarios move from outlier to live possibility. Third, watch the track shifts measured in tens of miles. A wobble south puts Guam's 153,000 residents closer to the core. A wobble north concentrates the worst on Tinian and Saipan, home to communities still rebuilding from April. Beyond the weekend, what remains of Bavi will move into the Philippine Sea, with longer-range guidance pointing toward Luzon, Taiwan, or Japan, a second act for next week that will depend heavily on how much the Marianas Passage disrupts the core. The bigger story does not end when Bavi does. This is the second time in 2 weeks the Western Pacific has spun up a top-tier storm on a compressed timeline over the warmest, thickest layer of ocean heat on Earth, with a Pacific-wide warming signal underneath it. The science says explosive intensification is becoming more common. The observation gap says our measurements of it will keep arriving with an asterisk. And the map says the next one of these will, sooner or later, aim at somewhere with far more people and far less practice than the Marianas. For the next 48 hours, though, the story is simple and specific. 200,000 Americans, a storm forecast to arrive near Category 5 strength, and a forecast detail measured in a few dozen miles that decides which islands take the core. We will be tracking every advisory as it comes in, and when the real numbers finally emerge from behind the satellite estimates, you will want to see how close they came.